Yes, I think it's done, right?
Yeah. Okay, so I started the recording, and I would like to welcome everybody to the third session of the Open Dais project. And I'm really glad to see many people joining. So we have more than 40 people today at the start of our talk. And I'm very glad to introduce today Professor Dr. Jorge Victória Barbosa from UNISINOS University, Brazil. So he will have a talk today about the temporal modeling in the context of aware computing. So Professor Barbosa, so take the stage and guide us today.
Thank you very much. Well, then thank you, Professor Ivan, for the presentation. And now we can start the talk about this topic. I think we will need 60 minutes, maybe 90, right? But I would like first to say you that one important aspect related with this presentation is that the presentation is a guide. We will see during the presentation several links that you can use to access papers that my group have published during the last years. And I think this is a very interesting aspect then, because you can study more about this topic, and you can get more information about each idea that I will present for you now. Well, then the title of the presentation is Temporal Modeling in Contextual Computing. My name is Jorge Victória Barbosa, and I'm a professor here in Brazil in the UNISINOS University. And it's important to say too that this presentation is strongly based on a specific paper that I have published 2 years ago, that you can see here, I think. You can see here, right, even the pointer that I'm moving or not?
Yes, pointer is
yes,
visible.
Very good. This is the reference that is the base for this presentation. Then you can access this paper to read a great part of the content that you see now. I have more information in the presentation. I have expanded with more information, but the main ideas are registered in this paper that you can see. I will try access here. We are going there.
Sorry? You are sharing only the presentation.
Are you seeing only the presentation, right? True. And I would like to show you this. Then I will change a new share screen now. Don't worry. Now we can try again. Now you can see
yes, now I can see it.
Yeah. This is the paper that I have published. That is the guide. That is the base for this presentation. Then you can access the PDF and read about the ideas related to that I will show you. Well, you can follow. Right. On this kind of link, you see several times during the presentation. All these links are related to papers published in journals and during the last years, or well, let's go. Then I think important aspect too is that this content, this idea related with the use of contextual computing to model the time and to support the computer systems based on time is an idea that my group have been working during the last maybe 10 years. And there are a lot of master theses in PhD theses too. Then you can, if you are interested in this topic, we can change more. I can change more information with you in the future. Well, then our scheduling is composed of these 6 topics. An introduction, I will talk about the past, and because the time, as you know, intuitive, is organized in 3 in three aspects, right? The past, the present, and the future. And the first part of the presentation will talk about the past, after about the present, and the future. In this topic, specifically multi-temporal context awareness, I will tell you about an effort that we have to integrate in computer systems, right? The modeling of these three aspects of the time, and to support the use of the context information in these three aspects of the time. Well, this is not our schedule then. So first, an introduction. All this content is organized, is guided by the ideas of two classical researchers, Mark Weiser and Satyanaran, right? These researchers created the concept of ubiquitous computing. Is a kind of computing that is present at any moment, at any location, and supports several intelligent services during our movement. And this kind of ubiquitous computing is a kind of omnipresent computing that supports a lot of service continually in our life. Was introduced then by these two researchers, and that paper that I showed in the beginning of the presentation, you can find the reference to the works of Weiser and Satyanaran, always registered there in that paper. Then you can see after the presentation or during the presentation. All right. Well, basically, ubiquitous computing. And in the ubiquitous computing, there is a specific concept that is context-aware systems. This term was created by Dais and a group of researchers that work with him. And also, you can find the specific paper of Dais and his group, right? But the concept of context-aware systems is basic to support the ideas that I will present to you now, because the idea is that we organize. This is the main idea of this presentation. We organize all information related with the entities in the world, all right, using a pattern, structure of informations, strategic informations to describe the reality of the entity. What kind of entity? Maybe a person, maybe a car, maybe a account, maybe any kind of entity that we are interested in model information related to it. And this strategy is basic to support the past, the present, the future, as I will show you next slides. Well, this kind of the information can be organized to support several applications, as I put here, application area. And I think we are walking in the direction of a disruptive technology. I'm not talking about the context-aware systems or ubiquitous computing. I'm talking about the use of this kind of information, contexts, to support the three aspects of the time. Because if we can support the three aspects of the time, we can model the past, the present, and the future in computer systems. And then we have a general support, a general vision of the life of the entities. And this is strategic to create the computer systems. Well, then the idea is discussion in this presentation, the context modeling in the time and how these concepts are related. How can I use the context modeling and the time integrated? And as you know, I told you, the time dimensions, the time aspects are the past, the present, future. And all we know and all you experiment in our days, these three dimensions, right? But why can we model these 3 dimensions using specific data and integrated these in computer systems. This is the problem. Well, this problem I call multi-temporal contextual systems, or a kind of system based on context and context aware that try to support the 3 multi-temporal, the 3 aspects of the time. This is the idea. All right, let's go then. And first dimension, remember, wait, here, past, present, and future. First, the past. Here we are. The past. Well, the past, as you know, is the time that we have lived and have experienced. And in computer science, we can use the context information to organize, as I told you, information related with an entity. For example, a person, right? A person I can know. This is a context model, a general context model that I am using here from master thesis. But it's only an example. Now you can see here, for example, the physical context is information related with this entity, a people, a person. Think about a person specifically, right? Then we can have information about the location for where is this person. We can have information about the time. What time is now for this person, right? These are the context information about entity. Where is it? What time is now? What is the temperature of the body now? Is the other strategic information now with a specific application, for example, for health. But I can create a context model, a lot of my structure of data that describe the strategic information that I would like to know about the entity, the person, or the car, or the animal. I don't know. This can be used in a general way, right? And this information is the context model that describes this person. Then, when I model the past, I will register this information related with the person at several moments. For example, I register all the information. All the information is registered 1 time, twice, 3 times. Then the time is going, and I am registering context related with this person, and then I am creating a context history, a history of context. Then this is the past related with this person. I will have several registers related with this entity using a pattern, a strategic pattern with informations relevant to a computer system, right? Some common information are the location, the time is relevant, but depending on the application, we can register, for example, vital signs for health, or a lot of other information for other, for example, a car, the velocity is relevant. Then we can have here velocity. But the idea of context history is general, is generic. Then I can apply to create different kinds of computer systems. Well, then I can use the same information to register, for example, the movement of a person in several places. For example, the person can go enter in the region and go up, goes out and create a history of locations, for example, that can be the same organization. Here, I put a relevant idea related to context histories. That is the interval that I would like to register this information. this aspect depends on the application. For example, to be very interesting to save the context with an interval of an hour or 1 minute or 1 second. Each application can have a specific interval to save the context information using the context model. But I think the most important aspect here, and is relevant to understand, is that this is a generic idea, right? That we can use to create computer systems using context. This is the idea of the past, all right? And related to the past, emerged several questions that I registered here, 3, to discuss with you, right? These questions are in that paper that I showed to you, but here I can ask them to you, and we can think about them. For example, is it feasible the use of generic software framework to manage context histories? I'm from the past. From this question, it's possible to create a generic framework to support, to use this idea in a general way? This question we try to answer in this paper here, and what in a model called Ubi Trail several years ago. Was the first paper that we have published related to the context histories. We can access this paper, and you can see the context distribution in trail-aware environments, right? Was published in the Journal of Brazilian Computer Society several years ago, 10 years ago. Well, let's go. Yes. Ivan, how's working?
Yeah, everything is working.
Thank you. Well, the second question related to the past I can ask is, can the storing of context be adaptive considering the context variability? Well, the idea is, if the context is with a specific kind of variability, I can change the information that is being registered during the time. It's possible to choose what kind of information will be registered at any time to create a more interesting organization of context histories. Well, this is the second question, and we answered this question with this paper here that we can access, and you can read the computation model for adaptive recording of vital signs through context histories. And this paper was published this year. Then I am talking about very recent studies and research for you. You can access before. So, the third question, relevant question: what strategies can we use to manage a large database of context histories? Well, this question we don't have yet an answer, because if you consider this kind of organization, the past can be years, decades, and we can register several years of information related to this entity. Then we will have a lot of information, big data and other kind of organization. Yes, this kind of solution is possible to be used to support the context history, but we didn't have discussion in this kind of organization of data, specifically with context history, because it's necessary to register this information using some kind of strategy to improve the the computer system that you use this information in the future. Because if I have 10 years of information of the past of a person, to read this information, to use this information, to access a specific information in 10 years of a history of a person can be very slow. You have a lot of specific problems to support this. Then the problem is not only to save the data, but how can we recover the data, the data in a adequate way. Well, these are 3 questions. Then we have studied really about them, about several others, but these are interesting. Then I choose to show in that paper and here to you. This is the past. All right, done. Let's go.
Yeah, looks like no questions for now.
Yeah, yeah, that's all. Well, then after the past, we have the present. That is the moment that we are living in this moment, this instant, or the present is now. Yeah, right? Then think about this. We have the past, context history. We have the present. We are here now. You have the future. It's the next step. But now we are talking about the present. Yeah. And to support the present, or a specific moment of an entity, we can use a concept called profile management of profiles. What is the idea? The idea is if we have a history, right? A history. We can create several rules. Rules are rules to inference, to infer the context history, and using this information, we can process and get a specific information and put in a register that describes the present of a person. Here we call this rule here aspect, and then we have created several concepts to organize this idea. But here is the profile of this entity, and the profile describes her present, and sure that this kind of information is limited, right? I need to choose what kind of information I would like to know about this entity in the present. For example, if we have a specific application to health, can be relevant to know how many times a person had fever, for example, during his life. Well, each fever is registered in the history, because the history has all the information related with the past of the entity. But I can have a specific inference, a specific rule, use it to count the fevers that the person had in his life, her life, right? Then the rules here, 10, 11, 12, 13, and in the present, I have a specific information related with how many fevers this person had in his life, or any other kind of information that I consider relevant to know in this moment. If I don't need to process this information, because I can use these rules are always working, and they are always running, and our counting, our creating some kind of inference that can be complex inference. I present to you a very simple inference, count the numbers of an event, but can be an equation, can be a rule, a complex rule using other rules, right? And I will have the profile of the person at each moment. This can be used in computer science, for example, to recommend specific behaviors for a person, or use it to some kind of alarm. And as I told you, this is a general idea to model the present using context information, because we are talking about this. You always must have this in your mind, right? We are talking about the use of context information, and we use this kind of strategy to support the past. Now we are creating a computational strategy, modeling the computational system to create the present, right? The present. And in this moment, we can ask 3 questions. Now, the present. It's feasible to use a generic framework to manage profiles. It's very similar to the first question in the past. But here, it's possible to create a specific profile, specific framework to support the ideas that I showed you. Yes, it's possible. We answered the first time this question several years ago, but we have worked with this idea in several other works. But the first time was here in this publication. You see now, we are going there. Are you seeing the expert system with application here?
Yes, it's visible.
Yes, a profile, a model for profile management applied to ubiquitous learning environments. A model for profile management. This paper describes that idea that I showed you now. The use of context histories to create the profiles and that describe the present of, in this paper specifically was applied to the education, ubiquitous learning environments, also learning environments. But the idea is general and can be applied to any other kind of application. Let's go. Second question. How to explore the dynamicity provided by profiles based on context histories? Because there are a lot of dynamic aspects that can be considered using the profiles. The profiles can be expanded. I'll show you. Here, you can see any aspects, but these aspects can be expanded in a specific moment. For example, I can have 5 aspects, but after 1 hour, I would like to have 10 aspects. 10 aspects, because I consider that some aspects now are relevant to this person or to this entity. Then there is a dynamic aspect in the number of aspects, a dynamic aspect in the number of aspects that I can consider at it. And there are a lot of other dynamic characteristics related with this profile management. In this paper, we explore this idea. We created a model using context histories to support, as you can see, anesthesia alert system. The idea is that we can use that information to support a surgical room. And we show them a specific. Here you can see rules and aspects and this kind of discussion. I think it's not relevant to show you the paper. You can read, you can consider it after. And the third question, SandWatch is the system that was described in that paper. The third question, can the context history be used to turn the refresh interval of a profile according to the characteristics of the application? Well, can I use the information of context history to guide these dynamic characteristics that I have discussed with you? Can I use the information that the past has to decide if I will have a more one aspect? Now I will have more or less aspect, and this decision of the dynamicity can use the past. This is the third question. Well, this question is not answered yet in a satisfactory manner. Then we don't have a specific paper that discussion, but we have tried to solve this problem and to try to explore this idea in several other works. Let's go. This is the present. And, well, stop. Pause to evaluate the evolution of the presentation. What do you think? All right?
Yes, and so we have the question in the chat.
Yes.
So the question is, can we compare the data of this week and the last week, then delete the data which they're almost the same to save memory?
Yes, this is a question and affirmation. I think, yes, you see now that we can use, what's the name of the people, the person that you know, Ivan? Who you have?
From the question was from Shuai Hao.
I don't know, only to share the name. Well, this is a good question, and you can see in the future that we will enter in the next step in this presentation that this idea of use information, compare information of the last weeks or last period of the time can be used to decide. I will show you now in the future. For example, you can see that there are a lot of strategies to analyze the data and use this kind of analysis to support the decision of the dynamics that I have told you. Well, I think you can go next step. All right, let's go then. Well, remembering, I have talked about the past. I talked about the present. Now, I will talk about the future, because it's the third dimension, and it's interesting to think about this. The most complex dimension to be treated in the computer science, by the computers, but currently, I think, is one of the most important problems that computer science is approaching. Machine learning, prediction, several kinds of algorithms to prediction, all right? And some time ago, we didn't have data to try to predict with the precision that we can try now. And then the future, I think this dimension is more complex to be treated. Now is possible to be better work for us, I think. Well, then the future. The future in this kind of modeling that I'm talking with you is called context prediction. I will try to predict context future. There are several kinds of strategies to do this, but there is one specifically that I think is the most interesting, the most interesting to be applied, considering the concepts that I have present to you. Consider this aspect. We have, right, a lot of context histories related with, for example, people, right? Here we have history. Here we have history, right? The history is here. Here, here, history, other history, several histories of several entities, right? Then we would like to model, to support this specific person. Then we have the past. We have the present, current context, present, right? And we like to know the future. We would like to predict, we would like to infer the future of this person. Well, if we have her history here, right? We can compare his history with the histories of other people, all right? That, sure, considering that these histories are related, right? For example, it's the history of the health of people. Health of people have a lot of patterns. Then I can consider the histories of other people to infer the health of these people that I am interested to consider. Then I can compare his past with the past of other people, and through the similarity analysis, try to discover the future of this person. For example, here, if this person, right, has the context A, B, C, D, E is the same of the other people. Now he is leaving the F, right? Or F. I can infer that if all people that I have the histories in the database had the same history of these people, what occurred with them was G and H, these people will live the same context, G and H. The present, there is the future. I don't know yet what will occur with him, her, right? But if all people in the history that I have information in the life of all people occurred the context G and context H, probably will occur with this person too. Then it's a very simple example, but the idea is exactly this that you can see in this figure, right? If I have a great number of histories of other entities, I can use strategies of similarity analysis to infer the future of a specific entity that I am assisting now, in this moment, now, present, now. I can use the histories, past histories, and through the similarity, consider what will occur with this person. This is a very simple idea, I can say, but I can use several strategies to organize this in computer science. I can use ontologies, for example, and compare ontologies to try to find these similarities. I can use several kinds of information in organizations to consider the similarity analysis. Then this is the idea that in the context, right, context-aware computing, I can try to support the future context prediction. Let's go. Then 4 questions. How to model the context history in the future? How to model the context histories to accelerate the prediction. I would like to accelerate the prediction. How can we model the context histories of the past? How can we model the past to accelerate the similarity analysis? Is it possible to create a generic system to manage context prediction based on context histories, providing prediction servers to other systems? This question we answered some years ago with this paper. Oracon, an adaptive model for context prediction. It's a generic model that uses context history to context prediction. It's not a new paper, but I think it's one of the first papers related with this idea that was published. Well, let's go, right? If so, if it's possible to create this generic system, how can we treat the problem that there is no ideal strategy for all scenarios of prediction? This paper also, it's the same paper, right? Try to answer this question, because we know that there is not an ideal strategy to solve all kinds of scenarios of prediction. There are a lot of scenarios, and we would like to predict more or less precision, or more time or less. Then there are several scenarios, and we don't have a specific strategy. Then we can try to, for example, create 5, 6, 8 strategies to consider context history to context prediction. This paper discusses too. And last, the similarity analysis compares only 2 context histories. Only 2. Right? The similar. I compare one history with the current history. Similarity analysis, right? The question is, if you expand this strategy to compare several histories at the same time, will it be possible to predict patterns in future trends of entity groups? The idea is, if I can, the idea, can we compare through the similarity analysis or similar strategies several thousands of histories to discover patterns that guide group of entities, group of people, people in a city. Well, this is a good question. We published this paper, and you can go there. You have time. Span, a multi-domain model for sequential pattern discovery and monitoring in context histories. Discover discovery of patterns in the context histories to determine possible patterns in the future of entities. Well, let's go. Well, then we arrive in the moment where we will try to integrate the 3 dimensions. And this is the generic idea. We have the time. We are here. Right? We are living a specific moment instant in your life. Right? We are here. Right? We can use the context history to model the past, as I showed you. We can use the context history to infer the present, profile management. And we can try to discover the future with context prediction, right? This is the scenario that we have. Then, right? Then problem is how can we integrate these 3 dimensions in a specific model to computer science, to computer systems. We proposed a general idea to support this integration, right? I can see here, multi-temporal contextual server, a server where we have a central database where we have profiles, context histories, context models, entity models. We have a specific model to context prediction, other model to context history manager, the best, other model to context profile manager, the present, and we can support service related with the time, several applications. We have a specific application in the interface, for example, for health, other application for well-being, other application, agriculture, and then we can use these several applications, and we can use the several applications with a specific, a centralized approach, but we tried to create a first vision of how we can support the 3 dimensions in our software architecture. Well, to create that solution that I show you now, we need to answer these 3 questions. How to model the return to the past using context histories in case where contexts are related to the physical world, which sometimes cannot be recovered. Because if we would like to treat the past, sometimes we would like to return a specific state of a system to a past state, but sometimes not possible because it's the physical world. For example, we launch a missile, right? We cannot recover the missile. We can return the state of this specific system to a past state. Then it's not easy to treat the time because the time and the context histories and present are related with the present. Present, I'm talking about the real world, right? Then there are problems related with this idea that we need to think about. What performance problem emerged in a multi-temporal system when we have several applications that require adaptation real time? We need to think about performance. We are talking here about to use several context histories or several years about several people, all information supporting several applications. Then we need to think about performance. And if infer some context features allow updating profiles, can't context prediction to be used to infer future profiles? It's a very, very specific question, but it's interesting because we can try to create future profiles using context prediction. But this is a specific aspect. Well, we have created some models to concrete these ideas. For example, Oracon, UbiTrail, a profile to support the present, UbiTrail to support the past, Oracon to support the future. And recently, last year, a PhD student created Delphos. Márcio Martins is the name of this student. We finished the PhD. Delphos, that was the first time that we tried to integrate the three dimensions in a specific model. We don't publish a specific paper related with Delphos yet in English. Well, let's go. Conclusion. What time is it now? 1 hour, 60 minutes of presentation. Well, stop to think about our past now. In our past now, we have the presentation of.
One more comment while we post here. So
yes. I will return there.
What I have, in the chat. So from the same participant. So I have an idea. If you want to predict a people's particular future event, I believe most events have happened to others. So we can check who has the same characteristics. So we can trace back the people who has event X happened to him. It means that we need to check the similarity of the array.
Yes, a good idea too. Yeah, it's interesting because if you think about this kind of prediction is the most interesting aspect in all these models, and because it's not easy to infer the future using the past. But if you have the context histories, we can compare, as you asked him, asked me, we can find several solutions to try to predict using the information that we have. We can consider specific aspects. We can consider specific aspects of the people, as you told. It's interesting. It's interesting. Good question. Who asks this question? Several people ask the same question.
Yes, I think that yes, this is the same person. So I'm sorry if I'm pronouncing the name wrong, but the name is Hao Shuai.
Good. Thank you very much.
Yeah, thank you so much for the question. So if anybody else have
other
questions,
I answered the question too because I think I understand the well, then you can see, here. Well, then past, present, and future integrated in one specific solution. This is the idea. Well, and conclusion. We are going to do the last slide. Well, then this presentation was related to time and its dimensions. This we as I comment, all we know what is this because we live in the time, right? But computer science needs to improve the algorithms, the data structures, and the general systems to support these three dimensions, mainly in an integrated way, because it's not easy. For example, prediction, context prediction. The idea of context history, and we have data from the past is not new. We have a lot of systems that use the past information to infer or to try to organize the solutions. It's not new. What is new in this moment of the time that we are living is that we have a lot of information. We have a lot of information that we can get from smartphones, we can get from Internet of Things, and a lot of solutions, smart cities, and a lot of other solutions involving technologies to get information that data that we don't know what to do with all this information. We are beginning, we are in the first steps related with use all this information to treat mainly the future. Multi-temporal context awareness is the main problem that this research is approaching. How can we work with the three dimensions integrated? And trends and challenges. Well, there are a lot of challenges related to these aspects that I have talked with you. And I can register here other papers that we have published in this year, 2021, 2021, 2021. 5 papers published in this year related, for example, with similarity analysis of context history, the future. Remember, I told you some minutes ago. We have tried to use similarity analysis of context history to predict the future in project management. Here, this paper. Fifth prediction model for software project management based on similarity analysis of context histories, information software technology. Very relevant journal of software engineering and system information. This paper approaches exactly that idea that I showed some years ago. 4 years of work in a PhD thesis related with the use of context histories to support project management. Applications, trends, and challenges. How can we apply all these ideas that I have discussed with you in applications? For example, agriculture. Here, indoor plant, a model for intelligent service indoor agriculture based on context history. The use of context histories to help agriculture, the agriculture to improve the production and other aspects related with agriculture. Paper, vital signs. This paper used context histories, a computational model for adaptive record of vital signs through context history. Jorge Aranda. That's finished. He finished his master thesis. Let's go. Next, here. Mental health. Mental health. A model for assisting the treatment of anxiety disorder. This paper was published with Leonardo Paula. Discussion this idea of context related to mental health. And project management, I show you the same paper here. Similarity analysis. Well, dimensions, past, present, future. This is our scenario, and we are trying to solve this, the integration of these 3 dimensions and solve real problems using multi-temporal aspects, using all this information that I have present to you. This is the main idea. All right. Well, this is the end of presentation. Thank you very much. I'm the Professor Barbosa, my email, my receipt with these publications. Here is the mobile computing lab, it's Mobile Lab, where great part of this work was developed during the last years, 10 or more years, right? And if you would like to talk about these ideas, about the papers, about any other question, I am available to talk with you. All right? Well, so Ivan, I think the presentation is done, and I am available to talk. I hope the ideas were interesting for the audience.
Okay, so thank you so much for your talk. It was really interesting, and yeah, I'm also happy to say that we are actually working together with your Mobile Lab on some projects, because we are working with Rodrigo, we are working with Enrique on some very interesting topics. So we have pretty good and stable partnership for a few years already, I think. So yes, so I don't see any other right now questions or comments. And the good thing is that I really like that you're publishing your works not only in showing the conceptually how it's working, but you also have a wide range of applications which you are making. So this is also valuable because it shows that how this particular methodology, I think we can call it methodology work on practice. And this is very interesting. So just one question, when you're working with this information from the past and the present, so it's actually a big amount of information. So what approaches are you prefer to use or you're using when you're working with them? So maybe some big data analysis technologies or something like this.
I understand, thank you. I think this is a very important limitation in our work because we don't have a specific strategy or a sophisticated strategy to save the data to use in the future in the solutions, right? For example, we can save the information using an ontology and an ontology base, but there are a lot of limitations in performance to use the ontology directly. We can use, for example, a relational database, for example, but there are a lot of limitations with the support to use this kind of solution. And we don't have a good solution, and we don't have I think a specific solution. I think this is the better idea, a specific solution to save the context histories, to treat this information in a good performance. This is a problem because we don't have, for example, data sets based on context history to use in experiments, for example, because we are starting to save now in some applications. You see, then it's a problem. Good question. It's a good question. It's a good question.
Yeah. So actually, I think that we can discuss this offline because actually one of the areas where our lab and we're working in our university is designing the storages for some special use cases. So this can be interesting and joint point. Also, I see some new messages in the chat from Genival Gomez. And so firstly, I would like to thank Professor Barbosa for excellent insights. And I also would like to know your view of future challenges in this area. So can you try to highlight the future challenges?
Yes, yeah, I think, for example, one of the most important challenges is how can we use the context histories and great number of context histories and to infer the future in, for example, the patterns. How can we infer the patterns in a specific group of entities using context history, for example? I think the most important challenge and the most important trend is intelligence. How can we create intelligence using this data? What kind of algorithm? What kind of analysis? What kind of solution is feasible using database to create intelligence? For example, smart environments, smart cities, smart car, smart all kinds of smart things that we can use in your life, using our past and using the past of other people to help us, right? Also in this context, thank you for the question, Joneval. Joneval is a great partner here in the university. For example, the security and the data some data can be shared with other people. We need some kind of privacy. It's interesting. It's interesting. In the future, we will have the solution for these problems because the data we have a lot of data, we have a lot of information. We we don't have option. We cannot say I want not to use this information, this data, because the intelligence will depend of this treatment, the treatment of this information. Well, I don't know if I answered the question from Joneval, but I think the main challenge is the intelligence. How can we use all these concepts to support intelligence, this intelligent environment intelligence?
Yeah. Challenges are the great things because this will help us to move forward. So yes, and Geneva also posted that thanks. So I think that the question was answered. Actually, I'm really glad to see that today we have participants from China. So actually the first questions were coming actually from participants from China. And I know that it's really very late there right now, so much later than in India. So I think it's almost midnight or something like this. Okay, so if we don't have any questions or any other comments for our chat, so I see there is nothing in Q&A session and nothing new appearing in the chat. So since it's really late for some of the participants, I think that we can say thank you so much one more time to Professor Barbosa today. So it was very interesting talk. Thank you so much. I think that your work will definitely find new fellows. Video will be available shortly, so it takes for me in general 1 or 2 days to publish it on our YouTube channel. So one more thank you from Alexander Pinskoy, so as a professor from our university. So we are working together here, and
yes,
and yeah, looking forward for new presentations from your university and Open Dais. I know we discussed already some options for the future with you, so let's prepare something else interesting for our auditory.
Thank you very much, Ivan.
Okay.
Congratulations for the organization of this project.
Thank you so much. Yeah, thank you. So let me wish everybody have a good night, day, evening, whatever your time zone you have. So yes, thank you so much. And I think that's it for today. So thank you. Goodbye.
Thank you for all.
Bye.
Bye.